In this problem, we're asked to test the claim that commercial truck drivers violate laws requiring front license plates at a higher rate than owners of passenger cars. So because we're talking about the proportion of people who violate the laws, we're going to run a two-prop z-test. And to do this, you're going to go to Stats on your calculator and then go over to the Tests menu and then go down to number 6, which is your two-prop z-test. Okay, so once you're there, then we're going to put in for x1 the number of cars that violate the law, or the passenger cars, and N1 is the total number of passenger cars in the study, which was 2,077. The number of commercial trucks who violate the laws are 53. And total number of trucks in the study is 385. And then we're going to choose the alternative hypothesis, and that is that P1 is less than P2. And that's because we have the cars listed first in the problem. So this is about cars. This is about trucks. So since they said that trucks have a higher rate of violating the law, we want P2 to be greater than P1. And then you can choose calculate or draw, whichever one you prefer. And our test statistic is negative 1.58. Now, if you had switched these and put trucks first and cars second, then you would have had P1 is greater than P2, and your test statistic would be 1.58. So mathematically, it's fine either way. Usually, I would leave it in the order in which they give you the values in the problem. So they talked about cars first. Make cars the first thing just to make your answer match up with what they have in the homework. Then the p-value is 0.0570. Probably they want just 3 decimal places. I have that part cut off, so I don't know how many places they want to go. Usually 3 or 4. So what can we conclude? Let's see, what do we have for our significance level? We are using an alpha equals 0.01 significance level, which means that P is greater than alpha, and that tells me to fail to reject the null hypothesis. Okay? So we're failing to reject the null hypothesis. The alternative is the claim. So when you write your statement, then you would say, there is not significant, not sufficient evidence to support the claim. And then you can just write whatever the claim is. All right, so that's part A. That's running just a regular hypothesis test. In part B, we want to test the claim by constructing an appropriate confidence interval. So what I'm going to do is I'm going to look at my value for alpha. And that's going to give me the confidence level that I want to use. So if I draw the distribution, and we know that this was a one-tail test, right? This was a left tail test. So that means that alpha is this 0.01 area on the left-hand tail. So I'm going to balance that because with confidence intervals, we always have to have this area in the center. So there always has to be two tails going on. So I have 0.01 on the right-hand tail as well, and that means the center has to be 0.98 because we have 2% in the tails altogether, and that leaves 98% for the center. So when I run a 2-prop Z interval, this is going to be pretty similar to the 2-prop Z test. X1 is the 228, N1 2077, X2 is 53, N2 385, and the confidence level is 98 or 0.98, either one is fine. And that gives me a confidence interval of negative 0.0717 to 0.01597. And what I'm always looking for when we're testing a hypothesis with a confidence interval, I'm looking to see, does 0 fall within this confidence interval? And since it goes from negative to positive, that means 0 is in the interval, somewhere in the middle, and that means that we are going to fail to reject the null hypothesis again. So, same result. You're always going to have the same result because we're using that same significance level. So that's how you do that problem.